What are the different types of astronomers? Is Mars flat? Is there a gravitational limit for planets? And in Q&A Plus, could other civilizations be frozen in time? All this and more in this question show. It's time for the question show. Your questions, my answers. As always, wherever you are across my channel, if a question pops in your brain, just write it down. I'll gather them up and I will answer them here. All right, let's get into the questions. Page Potter, how do astronomers decide what gets observation time when demand exceeds supply? Yeah, one of the cool things about observatories is that they are free to use, that you don't have to pay any money to use any observatories, any of the space observatories. They're all free for anyone in the world. And so if you're an astronomer from Australia and you want to be able to get time on NASA Space Telescope, no problem. All you have to do is make the science case to the committee that approves time on the telescope. And time on the telescopes is extremely limited, that both the Hubble Space Telescope and James Webb, and really a lot of the world's largest observatories, are oversubscribed. So every year, the James Webb group takes in proposals from the scientific community for all of the science that they want to do on James Webb. And then they review all of the proposals and judge them. They say, well, is this an efficient use of time? What is the science case that is being made? What is the benefit of any interesting science that could come out of this? And that if you're asking for large amounts of time, you're going to have a harder time than if you just want an hour or 20 minutes or 10 seconds of time on James Webb. And then they allocate the time, and they know which objects are going to be visible to James Webb and which things are close to other objects. And so they try to bunch them up so it's going to observe with minimizing the amount of time that has to spend slewing around to different targets. And they have some discretionary time. So if something exciting happens, like there's a comet discovery or an interstellar object, then they can still make some observations of that thing. It comes down to the steering committee, the committee for each one of these telescopes, that sits down, analyzes all the proposals, plans out the year. And in fact, we did a special on Universe Today last year for the sort of major classes, the interesting proposals that were accepted last year. And I think we'll probably do it again. It's going to happen fairly soon. But we're up to 5. I think we're on series 5 of James Webb at this point, which is kind of amazing. When you think about how, we are halfway through what James Webb's original operating time was supposed to be. Think about that. Now it looks like it's going to last a lot longer than we had thought, probably more like 20 years than 10 years. But still, we've actually been using this telescope for quite a while and getting a lot done. Ilya Kuryakin, can even non-scientists apply? Yeah, you don't need to be an accredited astronomer. You don't need to be a professor. You don't need to have a doctorate. Anyone can apply, but you have to make the case that you're not going to waste their time. So if you've been vibe sciencing with ChatGPT and it's giving you a bunch of ideas and now you just want to get some time on the telescope to test those ideas, you're probably not going to make it. But if you have contributed to a lot of scientific papers in the past, you know what you're doing, then anybody and amateur citizen scientists have gotten access to these telescopes as well. So it is theoretically available to anybody who can make the science case to use them. Dr. Zab, if neutrinos travel slightly below the speed of light and a supernova is light years away, how can neutrinos from the explosion be detected hours before the light becomes visible? One of the cool ideas is that if you want some kind of advance warning of when a supernova is going to happen, then you look for a flash of neutrinos, and they will be ahead of the supernova by a couple of hours, maybe even a couple of minutes. And so there's this thing called the Supernova Early Warning Network. And this is a network of neutrino detectors on Earth waiting for that flash of neutrinos. And when they detect it, they will figure out where it originated. They will inform the big observatories on Earth. They'll be able to point their telescopes, and then they will watch the supernova happen. The network will only work within a few hundred, maybe 1,000 light years of Earth. So Betelgeuse would set it off. But people have proposed ideas that could expand the network all the way out to the size of the Milky Way. And so you would have this network, this warning of when a supernova is about to go off. And so the question you asked is, neutrinos go slower than the speed of light, right? They have mass, so they can't go the speed of light. And so how do they get to us first? And the answer is that they are able to escape the collapsing star faster than the radiation does. So one of the interesting things about neutrinos is that they can pass through matter unaffected. You are currently experiencing trillions of neutrinos going through your body from the sun after they already went through the Earth, right? They went through the sun, like they were generated at the center of the sun. They went through the entire mass of the sun. Then they went through the Earth, and now they're going through your body, and now they're heading off into space, and they will probably not be stopped by anything. And it's only when you have a gigantic volume of water and you are sending countless neutrinos through it that occasionally one will slam into a molecule of water and release this cascade of particles that you detect it. And so that same idea that they're getting out of the sun, they're getting out. So the supernova is happening. The star is imploding. It's piling up material at the center. And in fact, it really kind of looks like now the neutrinos drive whether or not you're going to get a supernova or whether you're going to get a direct collapse. So if there's enough neutrinos being generated inside the center of the star as it's imploding. And again, they barely connect with anything, and yet they are still an outward force that causes the star to explode instead of just wrapping up into itself into a black hole. And so the neutrinos just escape, while the radiation has to make its way through all of this infalling material. And that takes minutes, if not hours, for it to be able to happen. And so the neutrinos have a head start, and they are traveling slower than the speed of light, but not much slower. Like they're traveling, 99 point, I don't know how many nines, the speed of light. And so they are almost going the speed of light. And that's enough for them to be able to get that edge and to be able to get out. Again, neutrinos can go through a light year of lead, no problem. So, they're just not stopped by the imploding star in the way that the radiation does get stopped. Lubo in China, is there a gravitational limit of a planet to radically reduce the chance of a civilization to leave its own planet? Is the Earth just perfect for planes and rockets? There is a theoretical gravitational limit, and that is that the amount of fuel or propellant and energy required for you to be able to leave your planet exceeds the mass of your planet, right? That if you've constantly got sunlight that is falling on your planet, you've got energy coming, and then you need some kind of propellant. And so if you use up every kind of propellant on your planet and you build a gigantic rocket and then you use that to try and get off the planet, that is the limit. It's kind of surprising how much more massive of a planet you could still build a rocket. If you had a planet that had, say, twice Earth gravity, you could probably still launch a rocket. Now, the payload that you would get into space, you would need a Saturn V rocket, and you would be able to get just a couple of 100 kilograms into space. It'd be tough, but you could still do it. So Earth is very lucky in that we have a thick atmosphere, a habitable planet, and yet we do have a weak enough gravity that we can build rockets that can launch tens of thousands of kilograms into orbit. And that if the gravity well was bigger, then we would have a harder time being able to launch rockets. But it's not impossible. And so, once you get to 3 Earth gravity, then you're starting to sort of think about how you're going to use all of the propellant on your entire planet to be able to pull this off. And then you hit like 10 Earth gravity, you would need all of the matter in the universe to be your propellant, right? Like the rocket equation gets complicated fast. But I do sort of imagine there will be this time, or I sort of think in sadness that there will be this time when we run across this planet where there's an intelligent life forms down at the bottom of a gravity well that is so strong that nobody would be willing to go down it to rescue them, that there's no way to get back. That if you go into that gravity well, you're never coming out. And so they may be able to participate in the Galactic Federation. They're going to send messages. They're going to watch our media. They're going to think big ideas, but they are trapped at the bottom of their gravity well forever, and they can never get out. That's sad. We like fly by and we're like, sorry, the one thing we can't do is bring you to space. But, if you can get anything into space, like even if you do have to build a Saturn V rocket and then you can only get a couple 100 kilograms into space. That's a bootstrap, right? Then you go off and you find an asteroid, and you turn that asteroid into something more, and you can sort of find your way up. You can climb the ladder to get out of your gravity well. But if it's more than that, you're just stuck. RP1 for breakfast. Is Mars flat too? Mars is as flat as the Earth is. Or maybe it's less flat, because the Earth is a flattened ball, an oblate spheroid. It's time to shout out all the new $5 patrons and above. Paul F., Tozy, Joseph Zellmeyer, Mel Davis, Rob Walling, Charles Wohl, Jerry E. Powell, Jean Villeval, George, and Alan Scott Gable. Join the club at patreon.com/universe today. Vestralnice. Could you easily tell what different areas an astronomer, astrophysicist, and cosmologist have? Are there even more specialties that have had space as the research area? There's a lot of overlap between astronomers, astrophysicists, and cosmologists. So, like an astronomer is typically making observations of things that are giving off light. So galaxies, stars, clouds of gas and dust, exoplanets, and they are measuring them and trying to understand their workings. Astrophysicists are trying to understand the forces that are happening with objects out in space. So magnetic fields around neutron stars, black holes, accretion disks, the kinds of places where physics really kind of takes hold of what's going on. Well, like an astronomer can measure the light coming from a galaxy and tell you where the star formation is happening. An astrophysicist might be wanting to specialize in the mechanics of plasma in a star, a newly forming star, and what you would see and what causes the jets to come out of these stars. But they're very similar and they do very overlapping work. And cosmologists are generally concerned with, say, the Big Bang, with the origins of the universe, but also the large scale structure of the universe, the clusters of galaxies at the largest scales, the nature of dark matter and dark energy and what influence those have played on the history of the universe. But again, there's a ton of overlap. Plenty of astronomers are thinking a lot about the large scale structure of the universe. So there's a ton of overlap. And then, there are specialties. I would say the main other specialty is planetary scientists. So a geologist studies the Earth. A planetary scientist studies geology on other planets or atmospheres or water. And so that is something that is like another specialty. When I talk to somebody about Mars or Venus, I'm talking to a planetary scientist usually. Just Chris, if the farther away from us, the faster space is expanding, would the perception of us from there be the same? Yeah. So we stand here on the Earth and we look out into space, and except for a couple of rarities, Andromeda and M33 galaxy, the rest of the galaxies in the universe are moving away from us. Isn't that weird? Isn't it weird that they're all moving away from, like, what did we do that all the galaxies want to get away from us? We know what we did. But if you went to any one of those other galaxies, you would also see the same thing. All of the galaxies in the universe are trying to get away from you. And if you go to anywhere, you're going to see the same thing. And so, yeah, if you went out to the other side of the observable universe, you would look back. Our Milky Way would be just cosmic microwave background radiation. It would not have even formed yet. And yet it would still be moving away from you at top speed. Silas Miller, how powerful could gravitational waves get on Earth? Could we ever feel them and not die? Gravitational waves can never be very powerful this far away. That it required an incomprehensible feat of engineering to be able to even detect them in the first place, where you have the arms of these interferometers, the LIGO and Virgo and Kagra experiments, where you have lasers that are bouncing back and forth along a 10-kilometer long arm, but back and forth, back and forth, back and forth, back and forth, so many times, so that you're essentially getting the length of that arm, but multiple times. And then you're measuring this imperceptible, tiny little distortion in the length of the arm that is telling you that a gravitational wave has passed by. That you would need to be extremely close to the black holes that were colliding for the gravitational waves to cause you any damage. They would. When gravitational waves roll past the Earth, they are expanding and contracting space itself and the matter in the space. And so you would be torn apart and then put back together. But, once you've been torn apart, it's really hard to kind of put those pieces back together again if you're like close enough to a black hole. But there are other forces, intense radiation coming from the black hole environment, the tidal forces of gravity from those black holes. All of this would be very bad. And then you would add the feeling the gravitational waves as sort of insult to injury on top of that. But you'd have to be very, very close. So no, there's nothing close enough to us that could have us feel any kind of damage from the gravitational waves. Did you know that you can watch the same video with no ads and get a bonus question over on Patreon completely for free? We call that Q&A Plus. And this week's bonus question, could other civilizations be frozen in time? And I'll put a link in the show notes. All right, those are all the questions that we had this week. Thank everyone who put your questions into the YouTube comments, everybody who joined me for the live show. I'm not sure when the next live show is going to be happening. Still sort of trying to balance between clear skies, evenings, things like that. So, but there will be an event here on the channel. Now, I'm going to talk about our recent 10-hour monster that we just released and some other projects that we have in the works. But first, I'd like to thank our patrons. Thanks to Abe Kingston, Andrea Pedretti, Bear Lake Roofing, Brian Bodie, Caradwin, Chuck Hawkins, Commander Baylock, Cooper and Ellie, Darkfinger, David Gilson, David Matz, Evan.pro, Greg Feely, James Clark, Jeremy Madden, Jim Berg, Jordan Young, Josh Schultz, Marcel Smits, Micah Purcell, Nordspace, OneStepForAnimals.org, Paul Rohrbach, Ren Kaidu, Richard Williams, Sean Sargent, Stephen Fallon-Munley, Team 49, Telescopes Canada, Wolfgang Klotz, and Zeldaborg Galactic Defender, who support us at the Master of the Universe level. And all our patrons, all your support means the universe to us. So last week in Space Bites, I think, I mentioned that we were going to be releasing something big over the weekend, and we did. Now, it wasn't big in that it was groundbreaking. It was big in that it was like literally large. And that was our 10-hour black holes compilation video made up of the questions that we got in this question show. So we did 10 years of question shows. 300 questions related to black holes. It's a monster. And then we sprinkled a whole bunch of additional Easter eggs and interesting black hole facts throughout it. So, people were wondering why we did this. And there's a couple of things. One is that, there's a lot of AI spam here on YouTube where people are doing this like 10 hours of whatever to fall asleep to. And it's AI slop. And so it's not real. And people are just like churning this stuff out like a machine. So we figured like, why not make something that's good? Something that was crafted by hand over 10 years as kind of a legacy of my work as a science communicator. That would be kind of cool. And then I kind of like compilations. I watch a lot of video game streamers, and often when they sort of take the separate episodes that make up a longer game that they play, I'll watch it again just because it's all nicely packaged in one piece. And so we thought that might be interesting for people as well. So it was an experiment. But now we have this search engine so that we can just search through all of the episodes. Like, for example, I know that there are about 80 Lagrange point questions. So we could do a Lagrange point compilation. Although that sounds like agony. But I hope you guys enjoy this. It was a lot of fun. If you haven't already, if you need something to fall asleep to, we have made you this machine and you can now do this. But if you want us to do more of them, let me know. All right, we'll see you next time.